Welcome to Geometric Galaxy. Welcome students. In this video we will see exercise 2.2 question number 3. Here we need to verify whether the following are zeros of the polynomial indicated against them. In this question we have 8 subdivisions. We will see one by one. The first subdivision is p of x is equal to 3x plus 1 and x value is given as minus 1 by 3. We need to check whether minus 1 by 3 is the zero of the polynomial. Now we need to replace x by minus 1 by 3 in the given polynomial. So we will find what is p of minus 1 by 3. It will be equal to 3 into minus 1 by 3 plus 1. Now we can cancel the 3 in the numerator and denominator. So we are left out with minus 1 plus 1 which is equal to 0. Since p of minus 1 by 3 is equal to 0, we can say that minus 1 by 3 is the zero of the polynomial p of x is equal to 3x plus 1. The second subdivision is p of x is equal to 5x minus pi. We need to check for x is equal to 4 by 5. Here we need to substitute in the place of x 4 by 5. That is, we need to find what is p of 4 by 5. If we get 0, then it is a zero of the polynomial. Let us check now. P of 4 by 5 is equal to 5 into 4 by 5 minus pi. In the numerator and denominator, we have 5. 5 and 5 will get cancelled. So we will be left out with 4 minus pi. So the value of p of 4 by 5 is not equal to 0. Therefore, 4 by 5 is not the zero of the polynomial p of x is equal to 5x minus pi. Our third subdivision is p of x is equal to x square minus 1. Here the value of x is given as 1 and minus 1. We need to check for two numbers 1 and minus 1. We will do one by one. First we will check what is p of 1, then we will check what is p of minus 1. P of 1 is equal to 1 square minus 1. 1 square is equal to 1. Therefore p of 1 is equal to 1 minus 1. 1 minus 1 is 0. Therefore p of 1 is equal to 0. Next we will check for p of minus 1. P of minus 1 is equal to minus 1 whole square minus 1. Minus 1 into minus 1 is 1. Therefore, it will become 1 minus 1. That is also equal to 0. Therefore, we can conclude that 1 and minus 1 are the zeros of the polynomial p of x is equal to x square minus 1. The fourth subdivision is p of x is equal to x plus 1 into x minus 2. Here also we need to check for two values, that is x is equal to minus 1 and 2. We will check one by one. P of minus 1 is equal to minus 1 plus 1. In the place of x I have substituted minus 1. Then minus 1 minus 2. Minus 1 and plus 1 if we add we will get 0. Then minus 1 and minus 2 if I add I will get minus 3. 0 into minus 3 is equal to 0. Therefore, the value of p of minus 1 is equal to 0. Now, let us check for p of 2. P of 2 is equal to 2 plus 1 into 2 minus 2. 2 plus 1 is 3. 2 minus 2 is 0. Therefore, 3 into 0. 3 into 0 is equal to 0. Therefore, p of 2 is equal to 0. For both p of minus 1 and p of 2, we get the value as 0. Therefore, minus 1 and minus 2 are the zeros of the polynomial p of x is equal to x plus 1 into x minus 2. The fifth subdivision is p of x is equal to x square, where x takes the value 0. So, it is very simple to find the answer. P of 0 is equal to 0 square, that is p of 0 is equal to 0. Now 0 is the zero of the polynomial p of x is equal to x square. You have to note this point, students, because If a question is asked like, is 0 a 0 of a polynomial? Then here is the example for the question. Yes, 0 can be the 0 of the polynomial. Sixth subdivision is p of x is equal to lx plus m, where x takes the value minus m by l. Let us now check what is p of minus m by l. It is equal to l into minus m by l plus m. So l in the numerator and in the denominator will get cancelled. So we will be left out with minus m plus m. Minus m plus m is equal to 0. Therefore p of minus m by l is equal to 0. So minus m by l is the 0 of the polynomial. P of x is equal to lx plus m. Seventh subdivision is p of x is equal to 3x square minus 1, where x is equal to minus 1 by root 3 and 2 by root 3. Here we have two values for x. So let us check one by one whether it is a 0 of the polynomial or not. P of minus 1 by root 3 is equal to 3 into minus 1 by root 3 whole square minus 1. If I square minus 1 by root 3, the answer will be 1 by 3. So I can write this as 3 into 1 by 3 minus 1. But in the numerator and denominator we have 3, we can cancel 3. So we are left out with 1 minus 1. 1 minus 1 is equal to 0. So we come to the conclusion that minus 1 by root 3 is the 0 of the polynomial. P of x is equal to 3x square minus 1. Now we need to check the next number 2 by root 3. So p of 2 by root 3 is equal to 3 into 2 by root 3 the whole square minus 1. So 2 by root 3 if I square, 2 into 2 is 4, root 3 into root 3 is 3, therefore I will get 4 by 3. So 3 into 4 by 3 minus 1. Now again 3 in the numerator and denominator will get cancelled. Now we are left out with 4 minus 1, which is equal to 3. Here we can see that p of 2 by root 3 is not equal to 0. Therefore 2 by root 3 is not the 0 of the polynomial. P of x is equal to 3x square minus 1. The eighth subdivision is p of x is equal to 2x plus 1, where x is equal to 1 by 2. Now let us see what is p of 1 by 2. It is equal to 2 into 1 by 2 plus 1. Just replace x by 1 by 2. 2 in the numerator and denominator will get cancelled, and we are left out with 1 plus 1. 1 plus 1 is equal to 2. Therefore p of 1 by 2 is not equal to 0. We can conclude that 1 by 2 is not the 0 of the polynomial. P of x is equal to 2x plus 1. And that's all in this video, students. I will solve question number 4 in the next video of exercise 2.2. Thank you. If you find Geometrix Galaxy helpful, consider subscribing to my channel. And please don't hesitate to recommend this channel to your friends. Thanks for watching.